Imagine sinking into a darkness so complete it swallows the very idea of sunlight, where creatures glow like living lanterns, fish peer through transparent skulls, eels unhinge jaws big enough to swallow their own curiosity, and crabs literally farm bacteria on fuzzy claws beside underwater volcanoes. Down here, biology doesn't follow rules, it writes entirely new ones. This is a world of giants and miniatures, of animals that fuse into each other for life, of predators dangling glowing bait, and octopuses flapping ear fins like lost cartoon characters. It's a world so strange that if aliens ever visited Earth, we'd point downward and say, "Look there, that's your people." And the wildest part, we've explored only a fraction of it. So buckle in, because today we're diving into the deep sea, the place where evolution gets weird, nature gets creative, and the creatures waiting in the dark are unlike anything you've ever imagined. If you want to truly test the limits of what you think life can look like, you don't need to build a spaceship or sign up for some interplanetary mission. All you have to do is dive straight down into the deep ocean, preferably with a submarine, not just positive vibes, and let the darkness swallow everything you know about biology. The deep sea is the kind of place where evolution seems to work overtime without supervision, like nature's very own experimental basement. You know, the kind of basement where someone stores boxes labeled "Do Not Open," and the ocean responded by ripping the tape off anyway and saying, "What's the worst that could happen?" Turns out the answer is a lot, but in a fascinating way. The deeper you go, the more the water shifts from ordinary to something almost supernatural. At first the light dims, then it fades, then it vanishes entirely, so completely that you start questioning whether your eyes are even open. There's no sun, no warmth, no comforting horizon, just an endless, ink-black expanse pressing in from every direction like a cosmic void, with salt water seasoning. If you've ever walked into a room and forgotten what you came for, imagine an entire ecosystem living in that feeling permanently. Down here, the rules change. Actually, they don't just change. They get rewritten, rearranged, chaotically illustrated, and filed upside down behind a stack of glowing jellyfish. This is the zone where creatures evolve features that feel less like biology and more like a brainstorming session where somebody said, "Hear me out. What if its head was transparent?" followed by thunderous applause. Or, "What if it swallowed prey twice its size like a sentient sleeping bag?" followed by someone else adding, "Yeah, and let's make it glow too." If aliens ever visit Earth, they're going to be deeply underwhelmed by U.S. surface dwellers and then absolutely floored by whatever we've been hiding 6 miles below. They'd probably assume the deep sea is the dominant civilization and we're just warm, confused decorations. So much of the deep ocean feels impossible, even when you're looking right at it. A fish with a skull you can see through? That exists. A creature longer than a blue whale, made up of hundreds of smaller creatures working together like the world's most ambitious group project? Absolutely real. A predator with a mouth so enormous it looks like it's permanently rehearsing for a surprise birthday gasp? Yep, that one too. Down here, normal is the exception, not the rule. The strangest part is that all these organisms aren't weird just for the sake of being weird. Every glowing lure, every gelatinous body, every oversized jaw and underdeveloped bone structure is the result of millions of years of survival in a place that doesn't make survival easy. It's like evolution said, okay, the sun isn't helping you anymore. You're going to have to get creative. And creative they got. In fact, if evolution handed out creativity awards, the deep sea would sweep the ceremony, give a dramatic acceptance speech, and then disappear into the darkness again without explaining anything. But what makes this environment really magical is the feeling that anything could emerge from that void. Picture yourself descending in a submarine, the lights cutting thin beams through the water. Particles drift past like dust motes, floating in an abandoned attic. The only sound is the sub's gentle mechanical hum. Then something flashes, a pulse of blue, a streak of green, a spark of pink, not from your lights, but from something alive, something you can't quite see yet, something moving. The tension in the deep sea isn't horror, it's awe. It's the kind of awe that crawls up your spine and settles comfortably on your shoulders, whispering, you have absolutely no idea what's around you, and that's amazing. You're exploring a part of Earth that humans almost never witness, a world older, stranger, and wilder than the forests, deserts, or mountaintops we're used to. A world where creatures solve problems in ways that would make a biologist blink slowly and say, I'm sorry. It does what now? And as you drift deeper, the darkness stops being just darkness. It becomes a stage, because the stars are below you now, not above. Every point of light is a living thing, signaling, hunting, attracting, distracting, or simply glowing because the deep ocean told it to. You begin to realize that all these bizarre adaptations, transparent heads, dangling lures, ballooning jaws, spaghetti-like bodies stretching for meters, they aren't failures of nature. They're its masterpieces. By the time you reach the realm where the strangest creatures reside, you feel like a guest at Earth's most secret party. No invitations, no dress code, just an open mind and the ability to accept that biology, when left unsupervised long enough, starts inventing things that border on science fiction. And tonight, the spotlight is on the ones that break every rule we thought we understood. If you're ready, we're about to meet them. The deep sea has been waiting. Descending into the deep sea feels like crossing an invisible border, one that separates the familiar Earth from a parallel version operating on a completely different set of rules. Up here, sunlight keeps everything warm, colorful, and reasonably predictable. Down there, things change so dramatically that you start questioning whether you accidentally slipped into another planet's ocean and no one bothered to tell you. It's not just alien, it's alien with style. Imagine trying to send a selfie from this depth and getting nothing but a spinning loading icon. The deep sea is basically space, but wetter and with worse Wi-Fi, which is saying something, because space doesn't even have Wi-Fi. As the light disappears behind you, the water doesn't just get darker, it transforms. The blue fades to ink, and the ink turns into something even blacker, like the universe switched to a higher contrast setting. Human eyes weren't designed for this, Even with artificial lights, everything feels just out of reach, like the deep is politely suggesting, you can look, but don't expect to understand. The ocean at this depth is so dark that you could hold a flashlight a foot from your face and still feel like the shadows are winning. And the temperature, well, let's just say it's enthusiastic about making sure nothing is comfortable. The water hovers just above freezing, a constant reminder that warmth is a luxury reserved for the surface world. Touching it feels like dipping your hand into liquid winter. There's no sun to heat it, no warm currents to offer a break. It is always cold, the kind of cold that feels ancient, as if the ocean has been quietly storing this chill since the dawn of time, saving it for anyone bold enough to show up uninvited. But cold and darkness are just the appetizers. The real main course is pressure. Pressure so intense it sounds exaggerated until you start looking at the numbers. For every 10 meters you descend, the weight on your body increases by an entire atmosphere. Go deep enough, and you're dealing with thousands of atmospheres of pressure pressing in from all directions. This isn't the kind of pressure you get from missed deadlines or awkward small talk. This is the kind that could flatten a car like a soda can without even breaking a sweat. Humans aren't built for this kind of squeeze. Our bones, organs, and general structural integrity throw up their hands and say, no thanks, long before we reach these depths. That's why only specialized submersibles made of metal thick enough to make a battleship jealous can venture down here. And the deeper you go, the more the ocean starts to feel like it's testing your resolve. Everything becomes slower, quieter, heavier. Sound travels differently, bending and distorting as if it isn't quite sure where it wants to go. If you shout down here, and please don't, your voice would carry unnervingly far, warped into something that'd make you wonder if you're hearing yourself or something behind you shouting back. Even the water itself is different. It's denser, thicker, almost syrupy in its stillness. There's no current rushing past, no waves, no turbulence. Just a heavy, unmoving quiet that settles around you like a cloak. The silence is so absolute, it feels alive, like the deep is holding its breath while watching you explore. If outer space is a vast, empty void, the deep sea is a vast, quiet presence, aware, ancient, and endlessly patient. If you could hover here long enough without turning into a submarine-shaped pancake, you'd notice that the deep has its own architecture. Trenches carve immense scars into the seafloor. Some deeper than Everest is tall. Underwater mountains rise from the abyss, their peaks never even brushing the faintest touch of daylight. Narrow canyons twist through the gloom, and bizarre formations jut from the sediment like forgotten ruins. It all looks like the remains of a world built by creatures you've never heard of, shaped by forces you can't see. And yet, for all this strangeness, life thrives here, not in the way we expect. No coral gardens or bustling shoals of fish, but in quieter, more deliberate forms. Creatures drift like ghosts, conserving energy with every movement. Others cling to rocks, waiting patiently for the ocean to deliver dinner straight to their faces. Some grow bodies so gelatinous they'd fall apart at the surface. Others reinforce themselves with structures tougher than bone. Every organism is a response to the deep's demands. They are shaped, sculpted, and re-sculpted until only the strongest, strangest possibilities remain. The most astonishing part is that we've barely seen any of it. Estimates suggest that the majority of deep-sea species are still unknown, waiting down there in the endless dark, some glowing, some stretching, some drifting, some lurking. All of them living in a world we're only beginning to understand. Every expedition uncovers something new, something baffling, something that leaves scientists staring at footage and whispering, "What is that?" So as we descend fully into this abyss in the chapters to come, keep in mind that the deep sea isn't just a place. It's a threshold, a boundary between the ordinary and the extraordinary, a realm that laughs in the face of biological norms and builds new ones from scratch. Down here, the rules bend, break, and sometimes run off entirely. And we're only just getting started. If you've ever wondered what happens when evolution gets curious about architecture, allow me to introduce you to a creature that looks like biology. Started designing a normal fish, got bored halfway through, and decided to install a viewing dome for the sake of artistic expression. This is the barreleye fish, the deep sea's unofficial mascot of, wait, is that its head? It drifts through the darkness with a skull so transparent you can literally see its brain inside. If humans had this feature, we'd never win an argument again. Everyone would be able to see our thoughts halfway forming and immediately abandoning ship. But for the barreleye, this crystal clear cranium isn't a quirk. It's a strategy, a very weird, very effective strategy. Imagine floating in an environment so dark that even shadows feel bright. Food is scarce, predators are everywhere, and the only direction that matters is up. Not because the view is nice, there's nothing to see up there, but because prey silhouettes itself against the faintest hints of leftover light. So the barreleye evolved tube-shaped eyes that point permanently toward the ceiling of the ocean world. These eyes aren't just for looking upward. They are giant optical cylinders, the deep-sea equivalent of 2 telescopes glued into its face. The fish basically swims around with a built-in periscope, scanning the darkness above like it's expecting someone to drop a snack from the sky. Of course, there's more going on than just the direction of the gaze. Those tube eyes are hypersensitive light collectors. They're packed with receptors that make the most out of even the faintest photon drifting down from the world above. While other fish might be bumbling around hoping their instincts get them close to dinner, the barreleye is essentially using night vision goggles. The creature's entire hunting strategy is like waiting under a glass floor for someone to walk across it while holding a sandwich. But there's a catch, literally the whole head. The fish didn't evolve a transparent skull just to look futuristic. That dome is a full-blown biological shield. Many of the barreleye's meals are snagged from the tentacles of siphonophores, creatures that can be armed with stinging cells strong enough to ruin anyone's evening. The dome protects the barreleye's extremely delicate eyes as it maneuvers dangerously close to those tentacles, snatching bits of prey like an aquatic ninja with a safety helmet. So while it might look like it's wearing a bubble on its head for fashion reasons, it's really headgear for the most delicate heist operations in the ocean. Inside that clear dome, the eyes do something even stranger. They rotate. This isn't a simple glance to the side. These eyes can swing from upward to forward, like periscopes that suddenly decide, actually, let's check what's right in front of us too. That means the barreleye can spot prey above, then rotate its eyes to line up with its mouth as it moves in for the grab. Picture someone using binoculars to locate a cookie on the top shelf, then tilting the binoculars downward to examine whether their arm span is long enough to steal it. It's a multi-step operation, and the barreleye has mastered it. The face around all this optical wizardry is almost comically simple. The fish has an adorable tiny mouth, small enough to make you wonder how it ever plans on intimidating anyone. But intimidation isn't the goal. Precision is. It isn't lunging at prey with dramatic flair. It is calmly drifting, quietly adjusting its gaze and making a calculated strike. If the deep sea had a class ranking of animals that do their jobs with quiet efficiency, the barreleye would graduate top of its school, completely unfazed, blinking slowly from behind its fishbowl forehead. And let's take a moment to appreciate how difficult it is to exist in such an odd format. Most fish have scales, pigment, and some level of privacy regarding their internal organs. The barreleye, its brain and eye muscles are basically on public display. If deep-sea creatures had social media, this fish would be trending for accidental oversharing. But the transparency comes with evolutionary benefits. Light beams travel cleanly through the dome, avoiding distortion. The barrier keeps sensitive parts insulated from stinging tentacles and debris, and the whole structure reduces drag, allowing the fish to hover motionlessly, like it's conserving energy for a very long eternity of waiting. Its body is wonderfully specialized for this hovering lifestyle too. The barreleye barely moves unless it has to. The deep sea doesn't reward hyperactivity. Burning calories down here is the equivalent of spending your last $5 on a snack and realizing the next grocery store is 400 kilometers away. So it floats, adjusts its fins with tiny movements, and lets the currents do most of the work. In the darkness, patience isn't just a virtue, it's survival. Because of this patience, the barreleye's whole world is defined by slow, deliberate motion. It isn't chasing prey in a dramatic sprint. It waits until a tiny creature drifts above, then uses its rotating periscopes, aligns its shot, and makes a quick, efficient bite. If hunting were a sport, the barreleye would be the calm competitor who doesn't blink, lines up the perfect throw, and walks away with a medal while everyone else wonders how they lost to the quiet one. Everything about the barreleye defies the visual expectations we have for fish. It challenges our ideas about what bodies should look like and what senses should do. It looks like a prototype that somehow made it into full production, one that works unexpectedly well. And in the deep, where light is a rumor and dangers lurk in every drifting shadow, this strange glass-headed marvel thrives. The deep sea has many creatures that bend the rules, but few do it with the barreleye's serene confidence. It looks like the ocean gave it a transparent helmet, so it could see the world more clearly, and in doing so, it exposed just how wildly creative evolution can be. If the barreleye fish's transparent dome wasn't already enough to make it look like a deep-sea concept sketch that somehow escaped the notebook, the real show happens inside that glassy bubble. Hidden within the gelatinous dome are its famous tube eyes, massive, gleaming green cylinders that look like someone installed 2 night vision scopes into its skull with instructions to point these at everything suspicious. But what makes these eyes truly mesmerizing isn't the shape or the color, it's the movement. These eyes rotate, they swivel, they aim, they adjust with slow, deliberate precision like tiny biological turrets programmed to track the faintest hint of drifting prey. If you've ever tried to glance at the snack table at a party without turning your head and giving away your priorities, you already understand the barreleye's entire operating system. For most animals, eyes face forward or to the side and stay that way. Sure, humans can roll our eyes at people, and often do, but we don't rotate them 90 degrees upward while keeping the rest of our faces still. The barreleye, however, can. Its eyes usually look straight up, pointed at the faint glow above. But when the moment calls for action, those same eyes pivot forward, smoothly transitioning to line up with the mouth in a coordinated movement that feels less like biology and more like the careful choreography of a machine designed by nature's most eccentric engineer. Inside the head, these eyes sit in fluid-filled capsules, protected and lubricated so they can rotate without friction. They don't pop or protrude. Instead, they glide, reorienting themselves with a serene slowness that suggests the fish has mastered something deep-sea creatures are not known for: patience with dramatic flair. The rotation is not frantic or twitchy. It's steady, measured, almost contemplative, like a creature that has all the time in the world to monitor its surroundings. After all, in the deep sea, rushing rarely leads to good decisions. The darkness favors the quiet, the still, the observant, and the barreleye is a master observer. That ability to shift its gaze between vertical and horizontal tracking gives the fish a rare advantage. Most predators have to decide whether to look up, down, or sideways, but the barreleye can seamlessly switch perspectives. When prey drifts overhead, silhouetted against the gloom, the barreleye looks straight up, its tube eyes acting like twin telescopes, gathering whatever scraps of light filter through miles of ocean. When it's time to eat, the eyes rotate to face forward, aligning perfectly with its small but precise mouth. It's as if the fish goes from watchtower guard to targeting mode in a single fluid motion. Imagine how this feels from the prey's perspective, if they even have a perspective left. One moment, the barreleye seems disinterested, just hovering, gazing upward like a fish lost in existential thought. The next moment, its eyes roll forward, the gaze sharpens, and it moves in with a kind of quiet purpose. No sudden lunges, no dramatic chases, just a smooth glide and a precise bite. If predators could hunt with the energy efficiency of a librarian reaching for a book, this is what it would look like. The rotating vision system also lets the barreleye judge distances with unusual accuracy. In a world where light is almost non-existent, depth perception is a constant challenge, but the barreleye adapts by using its repositionable eyes to get multiple angles on an object. Look up, see the silhouette. Look forward. Determine the exact location. Act only when the geometry is perfect. It's a methodical creature, the kind of predator that probably calculates angles without realizing it. You can almost imagine the equations appearing inside that clear dome like a strange, fishy heads-up display. Even more fascinating, the barreleye doesn't seem bothered by having its entire visual system exposed. Those green lenses stare out from inside the dome with a kind of Zen composure. They move independently but harmoniously, as though following a quiet rhythm. And because the dome refracts light softly around the eyes, it prevents distortion, giving the barreleye smooth, clear vision, even in a world where clarity is as rare as warmth. The humor, of course, comes from the way this fish uses its eyes with such casual discretion. There's something deeply relatable about its upward glance. The barreleye spends much of its time pretending not to care, lazily floating, pretending not to notice potential prey overhead. Then, with the slowest and most suspicious eye rotation in the animal kingdom, it checks again, subtly, quietly, hoping no one saw. It has the exact same energy as someone at a gathering who desperately wants another slice of cake but refuses to make direct eye contact with the dessert table until they think they can slip over unnoticed. Those carefully aimed glances aren't just funny, they're essential. They allow the barreleye to survive in a place where food drifts unpredictably and life depends on timing. Its strange visual choreography is the result of millions of years spent perfecting the art of not missing anything important in the darkness. While other fish rely on speed or brute strength, the barreleye relies on observation. It watches, it tracks, it moves with the calm confidence of a creature that doesn't need to rush because it sees everything coming long before it arrives. And that is the true brilliance of the barreleye's rotating turrets. They're more than eyes, they're a strategy, a way to turn a transparent skull into a panoramic surveillance system, a way to thrive in a world where guessing wrong means going hungry. It may look like it's discreetly checking the snack table, but make no mistake, those eyes are always working, always listening for the faintest hint of movement in the dark. In the deep sea, the barreleye doesn't just see, it anticipates. And in a realm where every advantage counts, that might be the cleverest trick of all. If you ever wanted proof that the ocean doesn't follow the normal rules for what a creature is, allow me to introduce the siphonophore, a living loophole in the definition of individual organisms. At first glance, a siphonophore looks like a single unified animal, a long drifting ribbon of tissue, sometimes so delicate it appears sculpted from strands of glass. But the truth is stranger, far stranger. A siphonophore isn't one creature at all. It is many creatures fused into one continuous body, each section acting like a specialist in an underwater assembly line. Imagine a group project where every participant is permanently glued together, forbidden from quitting, and, unlike every real group project in the history of the universe, everyone actually does their part. To understand how bizarre this is, picture a colony of tiny organisms deciding one day that teamwork is so important that individuality is optional. Each component, called a zooid, begins life genetically identical to its neighbors. But instead of developing into a fully functioning, independent animal, every zooid takes on a specific job and never switches roles again. Some zooids become floaters, keeping the entire colony buoyant. Others become swimmers, flapping rhythmic bells to propel the whole structure forward. Some become tentacles covered with stinging cells. Others specialize in digestion, basically living stomachs whose sole purpose is to process whatever the tentacles capture. It's a circus troupe where everyone trains for one act, performs it forever, and lives permanently attached to the same giant trapeze. This raises a philosophical question. Is a siphonophore a single organism or an entire society? Scientists call it a superorganism, which is a polite way of saying biological nonsense that works. Each zooid is so highly specialized that it can't survive on its own, yet the entire colony depends on the flawless performance of every one of them. A floating zooid community, all tethered together, sharing nutrients, information, and motion. In many ways, the siphonophore is less like a traditional animal and more like a living corporation, where each department has one job and one job only. But instead of sending snippy emails, the zooids coordinate seamlessly through shared tissues. This strange arrangement allows siphonophores to reach absurd lengths. Some species stretch longer than blue whales, and a few have been measured at lengths that would outdo most city buses, but they're not solid like a whale. They're fragile, gelatinous, and so delicate that even the gentlest submersible thrusters can tear them apart. To encounter a siphonophore in the deep is to witness a luminous thread drifting through darkness, glowing faintly with bioluminescence, undulating like a living line of cursive handwriting drawn by the ocean itself. Most animals have a clear beginning and end. A siphonophore feels like someone hit the repeat button on life and forgot to stop. The structure itself is astonishing. At the top, some species have a gas-filled float, a balloon-like chamber that provides lift. Below that, swimming bells create motion, pulsing rhythmically to gently push the colony through the water. Farther down, the feeding and stinging zooids form curtain-like arrays of tentacles that dangle like elaborate chandeliers. And deeper still, reproductive zooids handle the next generation. Every section is distinct, arranged like a sequence of specialized modules. If you cut the siphonophore into labeled slices, you'd have something resembling a very strange biology textbook diagram crossed with a malfunctioning blueprint. What truly sets the siphonophore apart is its coordinated hunting strategy. Those long curtains of tentacles don't just drift aimlessly. They form lethal nets, delicate but deadly, waiting for anything unlucky enough to swim into them. Each stinging zooid acts independently, firing when triggered, while the digestive zooids stand ready to break down whatever meal gets delivered. It's like a buffet line where every chef has a specific dish and the customers are unaware they're on the menu. Despite its gentleness of form, the siphonophore is an incredibly efficient predator. It doesn't chase its prey. It sets up an inescapable obstacle course and lets the darkness do the rest. The funniest part of all this is how cooperative the Zooids are. No drama, no rebellion, no slackers. If human group projects worked like this, every essay would finish itself. Every member would magically specialize in exactly what needed to be done, and no one would ever send a message saying, "Sorry, I forgot we had a deadline." The siphonophore is what group projects dream of becoming, but never will. Its lifestyle also challenges our basic idea of identity. What does it mean to be an individual? If you're a siphonophore, individuality is a quaint concept from simpler times. You are many, but also one. You have different body parts that are technically different animals. You're a colony, but also a creature. You drift, but every cell in your structure is hard at work. It's a paradox wrapped in a gelatinous glow, a quiet masterpiece floating through the infinite dark. And despite its surreal appearance, the siphonophore is perfectly tuned to its environment. Its body plan allows incredible flexibility, allowing it to spread out or contract its structures depending on conditions. Its bioluminescence can serve as camouflage, communication, or allure. Its delicate tissues conserve energy in a world where the luxury of constant feeding doesn't exist. It is refined, efficient, and astonishingly strange. Deep in the ocean's quietest chambers, the siphonophore drifts like a shimmering ribbon of intelligence, not the conscious kind, but the evolutionary kind, a kind that says, why be one thing when you can be everything at once? And in the deep, where survival demands creativity, the siphonophore stands as one of nature's boldest ideas brought to life. If the ocean ever decided to host a competition for most ridiculous biological flex, the siphonophore would show up, unroll itself like a glowing ribbon, and win by sheer length alone. Many sea creatures are impressive. Giant squids with planet-sized eyeballs, sharks built like underwater freight trains, but the siphonophore casually stretches farther than all of them, sometimes reaching lengths that make blue whales look like modestly sized appetizers. We're talking potentially over 100 meters long. That's longer than a basketball court, longer than a Boeing jet, longer than the line at a theme park on a holiday weekend. And unlike those lines, it doesn't get shorter when you complain about it. To truly appreciate this absurd length, imagine a creature that doesn't just exist, it unfurls. A siphonophore isn't thick or bulky. It's more like a translucent cosmic thread drifting through the dark, so fragile that a gust of water could tear it apart, yet so long it seems to defy every structural rule that normally keeps animals a sensible size. Standing next to one might feel like standing beside a floating, glowing rope that forgot to stop growing. And because it's made of hundreds or even thousands of connected zooids, each section contributing to a single living organism, it can keep expanding its reach like the world's most ambitious biological scroll. This incredible length isn't just for show. The siphonophore uses it to build one of the most elaborate hunting systems in the ocean, an arrangement so outrageous that calling it a trap feels almost too simple. This creature isn't laying a trap. It is the trap. Picture a deadly floating curtain stretching through the dark, invisible, until you're already caught in it. Each thread-like tentacle is lined with specialized cells called nematocysts, tiny biological harpoons loaded with toxins. When a passing fish or crustacean brushes against them, these cells fire with microscopic precision, injecting venom faster than the prey can realize. It has made a very unfortunate mistake. The siphonophore doesn't chase its prey. It doesn't lunge. It doesn't stalk. Instead, it sets up what might be the world's longest booby trap and simply waits for something unlucky to wander into it. Imagine decorating an entire underwater hallway with invisible tripwires and then letting the ocean itself usher victims straight into your trap. It's a chilling combination of elegance and lethality, all packaged into dozens of meters of near-transparent beauty. If this creature had a resume, extensive reach would be an understatement. These tentacles aren't thrown together haphazardly either. They form vast fishing lines that create a three-dimensional minefield. Each tentacle trails from the main body in long sheets or loose fronds, spreading wide to maximize coverage. Some siphonophore species arrange them in spirals, others in drifting webs, all designed to capture the faintest hint of movement. Prey doesn't even have to be particularly careless. Brushing against one microscopic section is enough to trigger the venomous barrage. It's like the ocean equivalent of walking into a spider web, except the web stings, paralyzes you, and then politely delivers you to its owner. Once something is caught, the siphonophore's efficiency becomes almost unsettling. Stinging zooids immobilize the prey. Then specialized feeding zooids move in, completing the task like an assembly line operating in absolute silence. There's no thrashing, no dramatic pursuit, just a quiet, methodical sequence. In the deep sea, drama is a luxury, precision is survival. The length of a siphonophore isn't just about hunting, though. It also allows the organism to occupy multiple ecological positions at once. Certain sections float nearer to high traffic zones where prey drifts, while others trail behind, storing energy or handling reproduction. It's a distributed lifestyle. Different parts of the organism experience different water conditions at the same time. Imagine your head being in one ecosystem, your torso in another, and your feet in a third, and somehow you're thriving. The siphonophore pulls off this strange spatial multitasking with ease. Part of what makes its extreme length possible is its delicate construction. Siphonophores aren't weighed down by bones or heavy muscle. Their tissues are mostly water, jelly, and thin membranes. This gives them buoyancy and flexibility, allowing them to grow without collapsing under their own mass. Their fragility isn't a flaw, it's an adaptation. Strength isn't needed when you float in a world without gravity's full grip, and when your greatest defense is simply being too ethereal to notice until it's too late. And then there's the bioluminescence. Many siphonophores glow, not aggressively, but with a faint, curtain-like shimmer that ripples along their bodies. The lights can serve multiple purposes: communication, camouflage, or misdirection. Some species display flickering pulses along their length, creating patterns that confuse predators or attract prey. Others produce sudden bursts of light to stun or distract. It's like the world's longest LED strip drifting through the abyss, except this one can handle meals and self-defense at the same time. Yet for all its beauty, encountering a siphonophore is a reminder that the deep sea doesn't play by rules we understand. How can something be so enormous, yet so delicate, so subtle, yet so deadly, so coordinated, yet composed of many individuals acting as one. Its existence feels like a riddle wrapped in silk, drifting between shadows. The deep ocean is full of monstrous hunters, but none of them approach the siphonophore's method. No jaws, no muscles, no chase scenes, just stillness, length, and a net of toxic tinsel waiting patiently in the dark. The siphonophore doesn't need to be fast. It doesn't need to be fierce. It just needs to be everywhere at once. An impossibly long, impossibly quiet trap that stretches through the deep like a whispered threat. Down here, the most devastating predators are sometimes the ones you never see coming. And the siphonophore, the world's longest booby trap, is always waiting. If the deep sea had a competitive eating league, the gulper eel would be the reigning, undisputed champion, the kind of champion who doesn't just win by a margin, but by swallowing the judge, the scoreboard, and half the stadium. This creature is the living embodiment of why chew when you can just engulf. The gulper eel drifts through the darkness, equipped with an anatomical party trick so outrageous it makes every other predator look like it's thinking too small. Its mouth can balloon open to a size larger than its entire body, transforming the eel from a sleek shadow into a floating, inflatable nightmare bag designed for maximum food intake. If nature ever held all-you-can-eat nights, this eel wouldn't just participate, it would headline. At first glance, the gulper eel seems almost delicate. Its body is long and ribbon-like, ending in a slender tail tipped with a bioluminescent organ that pulses faintly in the blackness. It doesn't have the muscular bulk of sharks or the armored plating of deep-sea crustaceans. Instead, its muscles are soft, its bones minimal, its body adapted to the low-energy lifestyle of drifting in near-total stillness. But this deceptive appearance hides the creature's signature feature, a jaw that looks like it belongs to a creature 10 times its size. The gulper eel's jaw is hinged in such a way that it can swing open like a trap door being yanked upward. Its lower jaw extends so far downward that the eel suddenly resembles a giant sock puppet gasping in surprise. The opening is not just wide, it's cavernous. The inside of the mouth expands into a spacious pouch capable of holding prey significantly larger than the eel itself. Imagine your own jaw stretching open enough to fit your entire refrigerator inside. That's the kind of energy the gulper eel brings to the table. Literally, this enormous mouth isn't simply for show. It serves a crucial purpose in a world where food appears approximately as often as honest assembly instructions. In the deep sea, meals arrive unpredictably. A drifting fish, a falling squid, perhaps an unlucky creature caught off guard by the eel's glowing tail lure. Rather than specializing in one type of prey, the gulper eel is a generalist of the highest order. If it can fit inside the mouth, and spoiler alert, almost everything can, the eel will give swallowing it a sincere attempt. The stomach matches the ambition of the jaws. It is incredibly stretchy, capable of ballooning outward to accommodate massive meals. As the eel engulfs its prey whole, its abdomen expands into a swollen orb, giving it the appearance of a long, skinny creature that accidentally swallowed a bowling ball. This transformation is both ridiculous and brilliant. It turns the eel into a mobile storage unit, a creature that can binge eat when the opportunity arises and then process its feast over days or even weeks. In the deep sea, gluttony isn't a vice, it's a survival strategy. The mechanics behind this feeding method are just as fascinating. When the eel opens its jaw to maximum capacity, water rushes in along with the prey. The eel then squeezes out the water while retaining the edible portion, like a biological strainer with extremely loose quality control. Because the eel's bones are flexible and its tissues gummy, everything shifts and reshapes as needed. This is one of nature's most extreme examples of adaptability, a body built to accommodate excess in the most literal way possible. The glowing lure on its tail adds another layer to its strategy. The organ pulses or waves in patterns that resemble the movements of small prey. In the darkness, the eel becomes its own bait, dangling a tiny neon sign that basically says, "Free snacks." Any fish drawn in by the glow soon learns the cruel truth. The sign is false advertising. The eel's body coils, the jaw swings open, and the glow becomes the last thing the prey ever sees. It's a one-fish carnival ride where the exit is technically available, but only in theory. What makes the gulper eel especially impressive is that it doesn't rely on speed or strength to capture prey. Its body is too fragile for high-speed pursuits, and its muscles too weak for dramatic lunges. Instead, it uses stillness and misdirection. It hangs in the water, tail glowing, body quiet, mouth at the ready. When prey wanders too close, the eel's jaw opens in a slow but decisive movement, more of a gentle scoop than a bite. There's no thrashing, no struggle, just a graceful and slightly unsettling moment where a creature disappears into a living shadow. And because the gulper eel's lifestyle is built on the feast and famine rhythm of the deep, its entire physiology supports long periods of inactivity between meals. After a big swallow, its metabolism slows to a glacial pace. It drifts, digesting in the cold darkness, conserving its precious energy. With such minimal muscle mass and such an efficient method of storing calories, the eel essentially becomes a floating stomach with fins. In many ways, the gulper eel embodies the spirit of deep-sea survival. Innovate or perish. Most predators became stronger, sleeker, or faster. The gulper eel chose none of those paths. Instead, it crafted a niche out of extreme flexibility, both literal and metaphorical. Its jaw is a marvel of biological engineering, its stomach a masterpiece of expandable design, and its hunting strategy a lesson in patience and opportunism. It's hard not to admire a creature that can swallow something larger than itself with the ease of a tourist stuffing themselves at a buffet. The gulper eel isn't just a participant in the deep sea's strange ecosystem. It's a reminder that survival can be as simple as opening your mouth at the right moment. And in the abyss, where food is scarce and darkness eternal, being the champion of all-you-can-eat nights is a title worth celebrating. In the deep sea, there's no visibility, no sunset glow, no moonbeam shimmer, just endless, eternal night. It's the kind of darkness that would make even a flashlight file a complaint. Down here, survival isn't about who's strongest or fastest. It's about who can stand out without getting eaten. And in this silent battlefield, some creatures have evolved the ocean's version of marketing campaigns, glowing gimmicks, neon teasers, and flashing advertisements. At the top of this creative hierarchy sits the gulper eel, a creature that has turned bioluminescence into its own personal billboard. If deep sea life ever organized a conference on effective marketing in zero-light conditions, the gulper eel would keynote with a presentation titled How to Win Friends and Influence Prey. Because yes, this creature uses light to lure animals straight toward its waiting jaws, an underwater strategy so clever you'd think the deep sea invented glow-in-the-dark marketing strategies long before humans figured out highlighters. Bioluminescence in the gulper eel is concentrated in a single remarkable structure, a small luminous organ at the end of its whip-like tail. This organ, called a siphonophore, is capable of producing steady light, pulsing flashes, or subtle glimmers depending on what the eel wants to accomplish. It's the only part of the eel that reliably glows. Its giant mouth doesn't shine like a neon sign, and its long body doesn't sparkle like a parade float. Instead, the eel hides everything except the smallest glowing teaser. It's the ultimate clickbait, a tiny, enticing signal in an ocean of darkness. The gulper eel wields this siphonophore with surprising finesse. Its tail bends and flicks with delicate movements, positioning the light exactly where it needs to be, almost like a puppeteer controlling a luminous marionette. Sometimes the eel drifts with the tail held directly in front of its body, the light suspended just beyond its cavernous mouth. Other times, the eel lets the tail trail behind and uses its flexibility to whip the glowing lure forward at a moment's notice. This versatility allows the eel to shift hunting strategies depending on conditions, whether prey is scarce, cautious, or plentiful. The light itself isn't random. Researchers believe the gulper eel can change the intensity, rhythm, and motion of its glow to mimic various small creatures. Some pulses resemble the flickers of tiny crustaceans, while others imitate the soft, drifting glow of plankton. To a passing animal, the sight is irresistible, a moving, promising morsel in a place where real food rarely announces itself. Prey drawn toward the glow isn't making a bad decision. It's making the only decision that makes sense in an ecosystem defined by hunger and darkness. But the eel's trick is about more than imitation. The glowing lure also serves as a distraction. The prey focuses entirely on the light, unaware that a mouth the size of a backpack is quietly hovering in the shadows beyond. The eel keeps its jaws tightly closed until the moment of opportunity. No dramatic rush, no sudden chase, just a smooth, silent approach. And then, with terrifying grace, the eel opens its mouth in a single sweeping motion. One moment the prey is investigating a harmless glimmer. The next it has been engulfed by what looks like a black hole with fins. Part of the magic lies in how well the eel hides itself, while presenting this luminous lure. Its body is slender, flexible, and dark, perfectly camouflaged against the abyss. Unlike many predators that illuminate themselves through glowing spots or shimmering patterns, the gulper eel doesn't waste its energy on showmanship. It lets the lure speak for itself. Everything else stays invisible. This contrast between brilliant bait and shadow body enhances the illusion. The light appears to be floating alone, disconnected from any danger. Of course, such a strategy invites an amusing image. If the deep sea really is like a vast underwater conference of strange beings, you can imagine each creature brainstorming ways to stand out. Some creatures would argue for glowing tips. Others would vote for twinkling stripes. The gulper eel would raise its tail and say, "Minimalism. One light, maximum results." If fish held marketing awards, this eel's lure would take first place for most effective use of a single light source. What makes the eel's tactic even more astonishing is that it uses bioluminescence not just for hunting, but possibly for communication. Some scientists think the light patterns may signal other gulper eels. Warnings, greetings, or perhaps even mating cues. In a world where sound doesn't travel far and visibility is non-existent, light becomes the closest thing to conversation. Even if the messages aren't complex, the ability to use light intentionally hints at a hidden layer of sophistication in this seemingly simple creature. The environment amplifies the effect. In the abyss, where light barely exists, a single glowing point can be seen from remarkable distances. Imagine walking through a pitch-black desert and spotting a faint lantern flickering miles away. You'd head toward it too. Curiosity, hope, survival instinct. The gulper eel knows this. Its lure is as much about psychological manipulation as biological mechanics. A small light in a starless world is irresistible. Not every hunting attempt succeeds, of course. Sometimes the prey approaches cautiously, stops short, and darts away. Sometimes larger predators take interest in the glow, forcing the eel to extinguish the light and vanish into safer darkness. But even with these risks, the tactic is so effective that the eel has relied on it for millions of years. It is one of the most elegant solutions evolution has ever produced for a place where nothing else works. In the deep sea, innovation is survival. Some creatures grow enormous jaws, some grow transparent heads, and some turn themselves into floating death traps. But the gulper eel? It taps into the ancient magic of bioluminescence and uses it like a tiny flashlight salesman, waving its glowing teaser around with just enough flare to lure in dinner. And for a creature that spends most of its life drifting silently through a world without light, it has mastered the art of shining exactly when it needs to, and disappearing the moment it doesn't. If you ever feel like the deep sea doesn't make sense, you are absolutely correct. And nowhere is its chaotic design philosophy more obvious than in the way it handles creature sizes. Down here, nature seems to have misplaced the part of the settings menu labeled consistency. Some animals become comically huge, stretching into lengths that would make surface creatures question their life choices, while others shrink down into adorable bite-sized versions of their relatives. It's as if evolution fell asleep on the keyboard and accidentally toggled both the supersize and shrink options at the same time, then shrugged and left them running for a few million years. This peculiar phenomenon, deep-sea gigantism and deep-sea dwarfism, creates an underwater world where size is dictated not by what looks normal, but by what works. And in the deep, where life is shaped by cold temperatures, crushing pressure, scarce food, and very little competition, what works turns out to be very different from surface logic. Take deep-sea gigantism first. Many species down here grow far larger than their shallow water relatives. Giant amphipods, for example, can reach the size of a small lobster, while their surface cousins barely rival a thumbnail. Deep-sea isopods look like roly-polies scaled up for a theme park ride, and giant squids boast eyes so huge that they could probably detect a surprise party happening 3 miles away. Even jellyfish, creatures already notorious for their whimsical disregard for size limits, stretch into massive, billowing umbrellas that drift like ghostly hot air balloons. Why does the deep encourage such dramatic enlargement? Part of the answer lies in the cold. Lower temperatures slow down metabolism, extending lifespans and giving organisms more time to grow. Think of it like a biological slow cooker. Things simmer longer, so they end up bigger. A longer lifespan means more time for cells to replicate, tissues to expand, and body plans to stretch into sizes unthinkable in warmer, more energetic waters. Another factor is the low predation pressure. In shallower environments, big bodies often attract big trouble, but in the deep, predators are fewer and farther between. Being enormous doesn't automatically turn you into a target. It sometimes makes you harder to mess with. A giant amphipod isn't exactly a fearsome creature, but its size makes it less appealing than the smaller, easier-to-handle snacks drifting nearby. Food scarcity also plays a part in gigantism. Strangely enough, being big can help creatures store more energy during lean times. A large body offers space for larger stomachs, bigger fat reserves, and the ability to process large, infrequent meals. When dinner appears once every few weeks, it pays to have the capacity to eat like you're stocking up for winter every single time. On the flip side of this giant parade, we have deep-sea dwarfism, species that shrink dramatically in order to survive. Small bodies require less energy, which is incredibly important in a world where calories are precious. Tiny organisms can feed on microscopic particles drifting down from above or scavenge scraps missed by larger creatures. Their size isn't a disadvantage, it's a strategy. By reducing their metabolic needs to the bare minimum, they stretch limited resources further. Some deep-sea species take dwarfism to an almost comedic level. The males of certain anglerfish species, for instance, are so small that they fuse onto the bodies of much larger females, becoming living fuel tanks whose only real job is providing sperm. It's an extreme adaptation born from the difficulty of finding a mate in the vast emptiness of the ocean depths. When partners are scarce, being tiny enough to hitchhike is apparently a valid evolutionary plan. Dwarfism also reduces the need for movement. The deep sea is calm, still, and quiet. No roaring currents or crashing waves. Smaller animals can cling to rocks, burrow into sediment, or hide inside tiny crevices where predators can't follow. Size becomes a shield through stealth rather than strength. And then there are the species that demonstrate both extremes depending on their life stage. Some deep-sea creatures hatch tiny, stay tiny for a long time, and suddenly balloon into massive adults once they acquire enough resources. A kind of surprise growth spurt that would baffle any parent-teacher conference. Their development is carefully tuned to the rhythm of the deep, with growth triggered only when conditions allow. All of this creates a landscape where size stops being predictable. You might encounter a worm longer than a sedan, followed immediately by a fully mature fish smaller than a jelly bean. Shrimp grow the size of cats, while sharks shrink down to palm-length cuteness. It is a world unbound by surface expectations, governed instead by the logic of survival in one of the harshest environments on Earth. The beauty of deep-sea gigantism and dwarfism is that it reflects the ocean's endless creativity. Life down here is sculpted not by what looks normal, but by what solves problems. Need to handle rare, massive meals? Grow huge. Need to survive on crumbs? Shrink down. The deep sea enforces no single direction. No size is too big, too small, too strange, or too ambitious. Evolution simply picks whichever path leads to survival, even if the result looks like nature lost its ruler and started estimating. In the abyss, life refuses to follow a template. Some creatures tower like underwater titans, others tiptoe like microscopic beginners, and many fall somewhere in between, each adapted to the silent demands of a world without light. And as you explore further into this realm, you begin to appreciate the delightful chaos of it all. Nature isn't inconsistent. It's experimental. It tries ideas that would never survive on land, rewrites its own blueprints, and occasionally throws in a surprise-sized change just because it can. Down here, the ocean doesn't just create life. It plays with scale like an artist playing with perspective, painting giants and miniatures side by side in a world where size is simply another tool for survival and never, ever predictable. If you journey far enough across the sea floor, past the drifting giants, the glowing hunters, the gelatinous phantoms, you eventually encounter a region that feels less like an ocean and more like an industrial underworld. Here, hydrothermal vents roar like underwater chimneys, blasting mineral-rich water into the darkness with the confidence of volcanoes that decided to try scuba diving. It's a landscape as extreme as it is alien, boiling plumes rising from cracks in the crust, the water around them shimmering with toxic metals, and temperatures swinging from icy death to scalding doom within a few fin strokes. Most animals avoid this place with the same enthusiasm people avoid a buffet labeled mystery shellfish. But not the yeti crab. The yeti crab, also known as Kiwa hirsuta, looks like it wandered out of a myth and into a science lab. Its body is pale, almost ghost-like, as if the darkness has leached the color straight out of it. But what truly makes the creature unforgettable is its claws, which are covered in dense, silky hairs that give it the appearance of wearing tiny, stylish white mittens. These bristly claws have earned the crab its name. It looks like the abominable snowman shrunk down, grew a shell, and decided to take a job in the seafood aisle. But those fluffy claws aren't just for show. They are the entire foundation of the crab's most astonishing behavior: underwater farming. The yeti crab doesn't chase prey, forage like other crustaceans, or rely on scavenging. Instead, it cultivates bacteria on its own limbs, yes, farms it, gently waving its hairy claws in the chemical-rich plumes of the hydrothermal vents to feed its microbial crop. If the deep sea had a county fair, this crab would win Best Farmer every year and then politely decline the ribbon with its fuzzy mitts. To understand this farming lifestyle, you have to understand the vents. Hydrothermal vents release superheated, mineral-laden water that is toxic to most animals. But the chemicals fueling these plumes, primarily hydrogen sulfide, are pure gold to certain bacteria that thrive on them. These bacteria don't need sunlight to survive. They use chemistry as their energy source through a process called chemosynthesis. It's like photosynthesis, except instead of sunlight, the bacteria run on ingredients that smell like rotten eggs and industrial accidents. The yeti crab has evolved a symbiotic partnership with these bacteria. Its hairy claws, called setae, provide an enormous surface area for the microbes to cling to. The crab positions itself in the perfect spot, close enough to the vent to supply the bacteria with the chemicals they need, but far enough not to cook itself like a forgotten dumpling. Then, with surprisingly gentle movements, it waves its claws through the water, constantly feeding the bacteria fresh chemical plumes while preventing debris from settling. Watching it wave its arms like that, you can't help but think it looks like it's trying to flag down a taxi no one can see. As the bacteria grow, they form a thick, nutritious layer along the crab's claws, its personal crop. When the microbes reach full maturity, the crab uses comb-like mouthparts to scrape them off and eat them. It is both the farmer and the harvest. This is efficiency that would make any agricultural engineer weep. What makes the crab even more charming is the sheer confidence with which it performs these motions. The constant slow waving creates an oddly peaceful rhythm, a kind of underwater Tai Chi that makes it look like the ocean's fluffiest farmer practicing relaxation techniques while tending to its bacterial orchard. If crabs had meditation classes, the yeti crab would definitely be the instructor, calmly demonstrating the vent-side microbe cultivation pose. In a world with so little food, this farming lifestyle is genius. Hydrothermal vents may be dangerous, but they are reliable. They release nutrients year-round, unaffected by seasons, storms, or surface conditions. While other deep-sea creatures rely on whatever drifts down from above, dead plankton, fish carcasses, or unlucky animals, the yeti crab grows its own meals in-house. It's the equivalent of having a garden in a desert. Whole colonies of yeti crabs gather around vents, forming dense, living carpets of pale bodies and waving claws. Dozens, sometimes hundreds of them, cluster together in shimmering clusters on the rocks. It looks like a silent assembly of miniature abominable snowmen gathered for a meeting about quarterly bacteria production. These crabs don't just tolerate each other, they require each other. More crabs waving means more circulation of vent chemicals, which helps bacteria thrive across the group. It's farming as a team sport. Their special adaptations don't end with farming. The Yeti crab's strange environment demands a strange physiology. It has reduced eyesight, barely functioning really, because vision is useless here. Instead, it relies on chemical cues and touch to navigate the deadly gradients of temperature and toxicity. Its legs are designed for clinging to rocks in turbulent currents, allowing it to maintain its perfect farming position. Even its pale color is adaptive. Pigment is unnecessary in an eternal night. Living on the border of a hydrothermal vent requires precision. Move too far from the vent, and the bacteria starve. Move too close, and you boil. The crab instinctively finds that narrow Goldilocks zone, warm enough for its crop, cool enough for its survival. That it manages this balancing act while waving its claws like a fluffy cheerleader is nothing short of remarkable. In the deep sea, survival takes creativity. Some creatures grow jaws that unhinge, some glow to lure prey, some stretch into living tapestries. And the Yeti crab responds to the abyss by becoming a tiny, hairy, bacteria-farming hermit with the calm determination of someone who has fully committed to the world's strangest agricultural career. It is the ocean's fluffiest farmer, tending to its microbial fields not with tractors or plows, but with patience, rhythm, and a fine pair of fuzzy mittens. And in a place where food is rare and danger is constant, the Yeti crab's bizarre farming practice isn't just adorable. It's one of the most successful survival strategies the deep sea has ever grown. If the deep sea ever produced a creature specifically designed to make even the most hardened marine biologist melt into emotional goo, it would be the dumbo octopus. This little marvel looks like someone dared evolution to create the most adorable thing possible in an environment traditionally ruled by nightmare jaws and invisible death traps. An evolution perhaps tired of making creatures with transparent skulls and inflatable mouths, said, "Fine, here's something cute, don't get used to it." With its round body, big eyes, and signature ear-like fins that flap gently as it swims, the dumbo octopus resembles a character who wandered out of a Disney storyboard and accidentally ended up 6,000 meters underwater. Its ears, of course, aren't ears at all. They're actually modified fins, broad, flexible appendages that extend from the sides of its mantle like smooth, fluttering wings. When the dumbo octopus swims, these fins beat softly and rhythmically, giving the whole creature a gentle hovering motion that feels impossibly serene for a world defined by pressure, strong enough to turn submarines into modern art. Watching a dumbo octopus move is like watching a floating pancake decide it's time to dance. The motion is strangely hypnotic, equal parts graceful and whimsical, as if the octopus is gliding through the abyss with all the urgency of someone browsing a bookstore on a slow afternoon. Unlike most octopuses, which jet around with bursts of water propulsion or creep across the seafloor like eight-legged shadows, the dumbo octopus is a master of minimal effort. It floats, drifts, and hovers with the kind of peaceful contentment that makes you wonder if it even knows it lives in one of the most hostile environments on Earth. The deep sea is pitch black, freezing cold, and crushingly heavy, yet the dumbo octopus moves through it like it's taking a casual stroll through a quiet park. The fins give it exquisite control, allowing smooth vertical rises and gentle descents, movements so effortless they almost look airborne rather than aquatic. This calm demeanor is partly a reflection of its lifestyle. Dumbo octopuses live far below the busy layers of the ocean, where predators are numerous and prey races through the water like caffeinated confetti. Down where they reside, food appears infrequently and slowly. The dumbo octopus doesn't chase prey. It simply drifts until something edible wanders within reach. Its diet consists mainly of small crustaceans, worms, and whatever else drifts by with the current. It collects meals one by one, using its webbed arms to envelop prey like someone quietly folding a napkin around a snack. Its body plan reflects this quiet hunting method. The dumbo octopus lacks a rigid internal structure. Its tissues are soft, delicate, and entirely suited to a pressure-filled world where sturdiness is a liability. Instead of fighting the environment, it yields to it. The creature's gelatinous body absorbs and distributes pressure, allowing it to thrive where others would be crushed. In this way, it plays the role of a gentle ghost drifting through a world built for the armored, the monstrous, and the bizarre. Even its reproduction follows this calm rhythm. Dumbo octopuses don't have a fixed breeding season. Instead, females carry eggs at various stages of development and lay them whenever conditions are favorable. This flexibility is essential in a habitat where seasons are meaningless and stability is unpredictable. The hatchlings emerge as miniature versions of the adults, tiny floating puffballs with fins that flap like they're trying to relearn how to be adorable on purpose. One of the more charming aspects of the dumbo octopus is its apparent lack of fear, even though that's not really emotion, but evolutionary design. In the abyss, predators are relatively scarce, and the dumbo octopus has few natural enemies. As a result, it doesn't flinch, dart, or ink spray like its shallow water relatives. It watches calmly, observes gently, and reacts with the urgency of someone who just woke up from a very restful nap. Submersibles that encounter them often describe the octopuses hovering inquisitively, seemingly unbothered by bright lights, whirring engines, or the existential dread that usually accompanies deep-sea exploration. Their coloration adds to the cartoonish charm. While many are soft shades of red, brown, or peach, the tones glow beautifully when illuminated, giving them the look of animated lanterns drifting close to the ocean floor. Their large, expressive eyes, adapted for the faintest hints of light, only deepen the illusion. They look perpetually curious, politely surprised, or mildly delighted, depending on the angle. But don't let their adorable demeanor fool you. The dumbo octopus is exceptionally well suited for survival in one of Earth's most extreme biomes. Its calm movements conserve energy. Its flexible diet ensures that almost anything edible is acceptable. Its soft body withstands horrific pressure without complaint. It is a creature of quiet resilience, thriving not through aggression or speed, but through adaptability and serenity. In many ways, the dumbo octopus is a reminder that even the strangest, darkest places in the world can create beauty. Amid the colossal squids, glowing predators, and tentacled traps of the abyss, the dumbo octopus hovers like a tiny, flapping ambassador of gentleness. It doesn't look real, and yet it is, perfectly evolved, perfectly suited, and perfectly captivating. It's almost fitting that the creature most likely to be mistaken for a cartoon is also one of the deepest dwelling octopuses on Earth. The dumbo octopus didn't ask to be cute. It simply evolved the fins it needed to survive and accidentally became the deep sea's most charming accidental Disney character. Down here, in the silent infinite dark, this little octopus floats softly from moment to moment, proving that survival doesn't always have to look fierce or frightening. Sometimes it can flap gently, glow softly, and carry an air of sweetness in a world built from shadows. If the deep sea had a resident drama queen, an organism that not only embraced theatricality, but made it a survival strategy, it would be the vampire squid. Its scientific name, Vampiroteuthis infernalis, literally translates to vampire squid from hell, which seems dramatic even before you meet the creature. But once you do, you realize the ocean wasn't exaggerating. The vampire squid moves through the darkness like a drifting piece of enchanted velvet, part squid, part octopus, and entirely committed to being the abyss's most stylish enigma. With its deep crimson color, cloak-like webbing, and habit of flashing bioluminescent signals, it gives off the unmistakable energy of a creature auditioning for the lead role in deep-sea theater. Despite the name, the vampire squid is not a vampire. It does not drink blood, cast shadows over underwater castles, or turn into a bat and fly away, which is a real shame, honestly. Instead, its vampire reputation comes from its coloration and the spooky way its arms connect with a web of dark tissue, forming what looks like a fabric cape. When it spreads this webbing wide, the effect is dramatic and eerie, like a creature ready to swoop across a moonlit stage. But when the vampire squid inverts the cape over its body, pulling its arms upward and encasing itself in a shadowy umbrella, it creates one of the most iconic defense poses in the animal kingdom, the cloak posture. This cloak is not just for show. When threatened, the vampire squid curls its arms upward, wraps the webbing tightly around itself, and tucks its head down. What emerges is a dark, spiky orb, because the inner surfaces of its arms are lined with soft projections that look like little fleshy spikes. The creature becomes instantly unrecognizable, transforming from a graceful, drifting animal into something that says, "I am round, mysterious, and mildly dangerous. Please reconsider eating me." If it were performing on stage, this would be the moment it dramatically flips its cape around and declares, "Behold, my final form," followed by applause from impressed fellow cephalopods. This flair for performance is even more notable when you consider what the vampire squid actually is: a living fossil, It sits in its own evolutionary branch, distinct from true squids and true octopuses, carrying traits from both but belonging fully to neither. It has 8 arms like an octopus, but also 2 long filaments that resemble the tentacles of squids, even though these filaments aren't used for grabbing prey. Its body is gelatinous and flexible enough to withstand intense pressure, yet it possesses internal structures that hint at ancient relatives. It is a chimera, an evolutionary mashup that persisted long after other lineages faded away. The vampire squid's lifestyle also sets it apart. Unlike many deep-sea predators that rely on stealth, speed, or glowing bait, the vampire squid is more of a passive collector. Its diet consists primarily of marine snow, the gentle flurry of organic matter that drifts through the depths, broken bits of algae, microscopic organisms, discarded scales, and other ocean leftovers collect on long, sticky threads of mucus secreted from its filaments. The squid then reels these filaments back in and eats the accumulated debris like someone methodically snacking on popcorn from a conveyor belt. It's a surprising choice for a creature with such a dramatic appearance. Imagine attending a theater performance where the star emerges from behind the curtain, folds its cape with impeccable flair, and then proceeds to nibble politely on crumbs. This low-energy diet suits the vampire squid perfectly because it lives in the oxygen minimum zone, one of the harshest environments in the ocean. The water here is so depleted of oxygen that most animals avoid it entirely, but the vampire squid thrives. It has one of the lowest metabolic rates of any cephalopod, an array of specialized gills, and a blood pigment that binds oxygen with efficiency that would make an Olympic athlete jealous. It moves slowly, conserving energy with every gentle undulation of its fins, drifting through the water with a calm that seems almost supernatural. Its bioluminescence is equally understated, yet effective. Instead of using bright lures or dramatic displays, the vampire squid flickers with delicate points of blue light, releasing glowing clouds of mucus when threatened. These clouds create confusion, swirling and twinkling in the water like faint underwater fireworks. While a predator investigates the decoy lights, the vampire squid glides silently away, fins fluttering like the hems of an enchanted cloak. It's an escape technique worthy of any seasoned stage performer. Leave a puff of glitter, make an exit in silence, and let the audience wonder where you went. One of the most charming aspects of the vampire squid is how little it cares about looking intimidating. While many deep-sea creatures evolved menacing jaws or glowing lures, the vampire squid doubles down on elegance. Everything about it is soft, slow, and deliberate. Even at rest, it hovers like an actor waiting in the wings for its cue, fins gently beating in a steady rhythm. Its movement has a balletic quality, as though it's practicing choreography in a world that will never see the full performance. And yet, for all its theatrical flair, the vampire squid is a master of survival. It thrives where others fail, using a blend of ancient traits, clever adaptations, and understated bioluminescence to navigate a world without light. It doesn't need speed or ferocity. It has strategy, creativity, and a silhouette dramatic enough to earn a lifetime membership in the Deep Sea Performing Arts Guild. In a realm of strange creatures, the vampire squid stands out not by breaking the rules of biology, but by performing them with style. It glides, it flickers, it cloaks itself dramatically, and through it all, it survives with the grace of a cephalopod who knows it was born for the spotlight, even if no one else was around to see it. If the deep had an audience, the vampire squid would take a bow, and honestly, it would deserve the standing ovation. If you ever wandered into the darkest, quietest corners of the deep ocean and stumbled upon a creature posing like it's trying to make a point in a boardroom, you would have found the tripod fish. It has the uncanny posture of someone who has been standing for so long that sitting down would now be a sign of weakness. This fish's entire lifestyle revolves around standing upright, literally, propped on 3 elongated fins like a patient, pale sentry surveying the slow currents. In a place where nothing moves without purpose, the tripod fish chooses stillness as its strategy, striking a pose so peculiar that even evolution probably raised an eyebrow before approving it. The tripod fish gets its name from the extraordinary length of its pelvic and caudal fins, the bottom 2 and the tail fin, which stretch into extended, rigid rods. These fins can grow up to 3 times the fish's body length, forming a tripod-like structure that allows it to stand on the sea floor. This isn't a momentary balancing act. This is a lifestyle. The fish stations itself like a creature perched on stilts, a poised figure anchored gently to the sediment. If deep-sea meetings existed, this fish would be the one stubbornly refusing to take a seat, standing with crossed metaphorical arms and silently judging the agenda. This standing behavior is more than just a visual quirk. In a habitat where visibility is non-existent and energy must be conserved with monk-like devotion, the tripod fish has engineered a niche based on patience, positioning, and impeccable stillness. It does not chase prey. It does not wander. Instead, it plants its fin stilts into the soft ocean floor and faces into the current, letting the deep sea flow do all the work. When organic particles, small crustaceans, or slow-moving animals drift by, the tripod fish extends its long pectoral fins, almost like wings, detecting and guiding prey toward its mouth with eerie precision. These pectoral fins are more than simple appendages. They are sensory instruments, packed with cells that detect pressure changes and tiny vibrations in the water. In the pitch-black deep sea, sight is a luxury few creatures can count on, so the tripod fish relies almost entirely on touch. Its pectoral fins wave gently, like delicate antennae feeling their way through the current. When something edible brushes against them, the fish snaps into gentle action, drawing the prey in with movements that are more practiced than they are predatory. It is slow, selective, almost polite, like someone accepting a snack offered at arm's length. Its eyes, though technically present, are nearly useless. At the depths the tripod fish lives, often over 3,000 meters, light is non-existent, and eyesight offers no real advantage. The fish has gradually abandoned visual dependence in favor of sensory adaptation. Its eyes have shrunk and become simplified, a reminder that in the deep sea, evolution strips away anything that wastes unnecessary energy. Why maintain optics when the world offers nothing to see? The tripod fish instead invests its biological budget into feelers, fins, and the uncanny ability to stand upright, like it's always waiting for public transit. One of the strangest aspects of the tripod fish's life is how it reproduces. Because potential mates are incredibly rare in the vast desert of the abyss, the tripod fish has adopted the ultimate backup plan. It is a simultaneous hermaphrodite. Any adult tripod fish can play both reproductive roles, meaning that when two individuals finally encounter each other, an event about as common as two people wearing the same obscure costume at a tiny Halloween party, they can instantly mate without compatibility questions. If no partner arrives, the fish can fertilize its own eggs. In a realm defined by isolation, this adaptability ensures the species' continuity. Its elongated fins are surprisingly sturdy, flexible enough to withstand currents, but stiff enough to keep the fish upright. When currents shift or the seafloor changes, the tripod fish picks up its stilts and slowly relocates like a mobile coat rack, reconsidering its placement. This mobility is not fast or flashy. It is deliberate and minimal, a quiet glide over soft sediment before it stakes itself down again. The fish's entire existence is a study in economy, moving only when necessary and feeding only when opportunity drifts directly into its waiting sensors. Seen from a distance, or more realistically from a submersible's camera, the tripod fish looks like a tiny underwater alien checking its surroundings with quiet skepticism. Its body is pale and translucent, blending into the dust-gray seafloor. Its fins stretch so elegantly that the silhouette feels almost artistic, like an abstract sculpture someone accidentally dropped into the ocean. But closer inspection reveals a creature perfectly tuned to its environment, shaped not by aesthetics, but by the patient demands of the deep. Its posture, still upright and impossible to forget, makes the tripod fish one of the most peculiar residents of the seabed. Whereas other animals swim, crawl, or dart with bursts of energy, the tripod fish responds to the perpetual quiet of the deep with a stance that says, "I'll just wait right here until the world brings something to me." And remarkably, the strategy works. In a place where every movement costs precious energy, the tripod fish's strange habit isn't laziness. It's brilliance. It is a sentinel of the abyss, a creature that thrives by standing at attention, fins outstretched, waiting for life to pass close enough to grasp. Its unusual pose may make it look like the fish that refuses to sit during meetings, but in reality, it's standing on the shoulders or the fins of one of evolution's most perfectly adapted ideas. Down in the quietest layers of the deep sea, the tripod fish keeps its vigil, upright, patient, a stilt walker in the dark, mastering survival simply by standing still. If the deep sea had celebrities, none would be more recognizable or more misunderstood than the anglerfish. This is the creature that launched 1,000 horror illustrations, jagged teeth, a void-like mouth, a face only evolution could admire, and the iconic glowing lure dangling from its forehead, like a tiny lantern advertising dinner served here. But beneath that nightmare silhouette lies one of the most fascinating survival strategies in the ocean, and perhaps the most intense romantic commitment found anywhere on Earth. In a world where light is rare, food is unpredictable, and potential mates are scarce enough to be considered cryptids, the anglerfish has developed biology so dramatic it puts every rom-com plot to shame. Let's start with the lure, arguably one of nature's most recognizable deep-sea inventions. The dangly structure, called an esca, grows from a modified dorsal spine. Inside the esca lives a community of bioluminescent bacteria that produce a soft, eerie glow. The anglerfish cannot produce this light on its own. It relies on the bacteria, which move in and set up shop like glowing tenants in a biological apartment. In exchange for a cozy home and nutrients, the bacteria illuminate the lure, creating an irresistible beacon in the abyss. To prey drifting in the dark, the lure looks like a small, edible creature, a tempting flicker in a world where meals rarely advertise themselves. The anglerfish, meanwhile, remains nearly invisible. Its skin absorbs light rather than reflecting it, and its body shape blends into the gloom like a living shadow. The fish holds perfectly still, dangling its glowing lure like a deep-sea street vendor shaking a bright sign. The moment something approaches to investigate, the anglerfish unleashes its signature attack. Jaws unhinge, teeth flare outward, and the mouth expands into the aquatic equivalent of a bear trap lined with translucent daggers. Prey disappears in a blink. Dinner happens so fast, it barely qualifies as an event. But while the anglerfish's hunting technique is impressive, it is overshadowed spectacularly by its approach to reproduction. To understand the depths of this adaptation, you must remember that the deep sea is enormous, sparsely populated, and devoid of dating apps. A female anglerfish may go her entire life without encountering another of her kind. For a species to survive under these conditions, evolution had to get creative. The result? Sexual parasitism, a phrase that sounds dramatic because it is. Female anglerfish are the monstrous giants you see in documentaries, ranging from the size of a softball to that of a small dog, depending on the species. Males, by contrast, are tiny, sometimes thousands of times smaller. They look like miniature versions of the species, stripped of anything non-essential. Their only real goals in life are to find a female and never let go. And they take that mission, in classic deep-sea fashion, way too seriously. When a male finally encounters a female, a near miraculous event in the vastness of the ocean, he doesn't serenade her, bring flowers, or even attempt a charming wiggle. Instead, he bites her, not lightly either. His mouth clamps onto her body, often near the belly, and within a short time his tissues begin to fuse with hers. Bloodstreams merge, organs shut down. He loses his independence, his digestive system, and any hope of personal space. The male becomes a permanent living appendage on the female's body, reduced to little more than a pair of functioning gonads with a heartbeat. It's the most extreme relationship commitment ever recorded in the natural world. Males who commit more intensely than any rom-com hero who promises, "I'll never leave you." From our perspective, this sounds horrifying. From the anglerfish's perspective, it's practical. The female gains a guaranteed source of sperm whenever she's ready to release eggs. The male, who would otherwise starve in the abyss, gains a lifetime supply of nutrients from her bloodstream. Everyone wins, except maybe the male's sense of individuality, which dissolves about 30 minutes after attachment. This dramatic sex life explains why female anglerfish are such fierce predators. They must hunt efficiently to fuel not only their own bodies, but sometimes several fused males. A fully grown female may carry multiple tiny partners attached along her flanks like oddly placed buttons. To see one drifting through the deep is to witness the biological equivalent of a floating Gothic romance novel. And yet, despite their fearsome appearance, anglerfish are perfectly suited to the calm, slow rhythms of the deep. They move little, conserving energy. Their bodies are squishy and flexible, designed to withstand the crushing pressure without wasting resources on unnecessary structure. Their jaws can engulf prey nearly as large as themselves, a crucial trait in a world where you don't pass up a big meal just because it's awkwardly shaped. The anglerfish's teeth, curved backward like hooks, ensure prey can enter the mouth but never escape. The fish's stomach stretches to accommodate huge meals, allowing it to feast and then survive long periods of scarcity. In the deep, survival means storing calories whenever possible, even if that means temporarily looking like a creature who swallowed a beach ball wrong. The bioluminescent lure, the predatory strategy, the strange proportions, all of it comes together to create a creature uniquely adapted for darkness. But it's the mating behavior that sets the anglerfish apart, a reminder that evolution sometimes solves problems with ideas so bizarre they feel borrowed from fiction. In the grand theater of the deep sea, where glowing predators drift through eternal night and survival demands creativity, the anglerfish holds a starring role, not because it's the most beautiful or the most graceful, but because it is wonderfully, unapologetically strange. Its glowing lure is a masterpiece of deception. Its hunting strategy is ruthlessly efficient. And its romantic life? Well, let's just say if Hollywood wants a love story about lifelong commitment, they've been looking in the wrong places. The deep sea already wrote one. It just happens to involve biting, fusion, and devotion that puts every rom-com couple to shame. If the deep sea had a nightclub, and let's be honest, with all the glowing creatures down there, it practically does. The colossal squid would be standing at the entrance, arms crossed, saying absolutely nothing while radiating the kind of energy that makes everyone instinctively behave. This creature is the unofficial bouncer of the abyss, a massive, silent guardian whose appearance alone could make even the boldest deep-sea predator rethink its evening plans. And most of that intimidation? It comes down to two unforgettable features: its eyes, which are the largest in the animal kingdom, and its terrifying arsenal of rotating hooks hiding inside muscular tentacles. Let's start with the eyes, because they deserve their own chapter, but I promise not to make one. Each eyeball of the colossal squid can reach up to 30 centimeters across. That's roughly the size of a dinner plate, or the world's most alarming contact lens. These eyes aren't just large for dramatic effect. They are highly specialized sensors designed to detect faint light from objects far away. A priceless talent when you live in a world where sunlight doesn't even bother to show up. In the darkness of the deep, where illumination is limited to bioluminescent flashes and the occasional drifting sparkle of marine snow, being able to see the tiniest hint of movement is the difference between surviving and becoming a snack. What makes colossal squid eyes especially impressive is how they detect predators or prey at great distances. When a large animal disturbs the water, it often triggers bioluminescent organisms nearby to glow briefly. The colossal squid's enormous eyes are finely tuned to spot these tiny flashes, ripples of light that hint at something big moving through the abyss. This gives the squid advance warning that something is approaching, whether it's a potential meal or something it should absolutely avoid. With eyes that powerful, the squid doesn't just react to its environment. It reads it like a book with backlighting. But vision alone isn't what earns the squid its fearsome reputation. Hidden within its muscular tentacles are rotating hooks. Yes, rotating, each attached to a swiveling base that allows it to pivot like a tiny, murderous hinge. While many squid species have suckers lined with sharp teeth, the colossal squid upgrades this design into something more industrial. These hooks can swivel in different directions, giving the creature a mechanical advantage that resembles a biological grappling tool. If deep-sea predators had toolboxes, the colossal squid's tentacles would be filed under heavy-duty hardware. These hooks serve a vital purpose, capturing and holding on to fast, slippery prey in an environment where encounters are rare and opportunities fleeting. One brush with a colossal squid is enough to understand why few animals ever win a wrestling match against it. Once those tentacles wrap around something, escape becomes less likely than seeing sunshine at 4,000 meters depth. The hooks dig in, the arms tighten, and the squid brings its prey toward a beak capable of cracking bone. It's not messy, just efficient. The colossal squid doesn't fight. It secures. Its entire body is built to be a powerhouse in the deep. Unlike the giant squid, which is longer but more slender and flexible, the colossal squid is broad and heavy, with thick mantle muscles and a more compact design. Its shape suggests sturdiness and raw strength, like the difference between a fencer and a weightlifter. The colossal squid isn't interested in elegant maneuvers. Its strategy is direct. Latch on, hold tight, and finish quickly. If the deep sea were a bar and chaos broke out, this is the creature you'd want stepping between you and trouble. Its metabolism, however, is surprisingly slow. Despite its massive size, the colossal squid conserves energy with the caution of a creature that understands how scarce food can be. It drifts more than it swims, relying on long tentacles to snag prey rather than bursts of speed. In the deep, reckless motion wastes calories you may not replace for days or weeks. The squid's enormous body is adapted to survive these feast and famine cycles. Like many deep-sea giants, it relies on a strategy of low-energy use, paired with explosive force when that single precious opportunity appears. And yet, for all its intimidating traits, the colossal squid isn't a villain lurking in the dark. It's a masterpiece of adaptation, one of nature's most remarkable answers to the pressures of a world without light, warmth, or predictability. Its eyes evolved to detect life in a near featureless expanse. Its hooks evolved to seize fleeting opportunities. Its immense size provides the presence and power needed to survive in a place where only the most resilient creatures thrive. Much about the colossal squid remains mysterious. Few humans have ever seen one alive, and the specimens we find are often juveniles or individuals accidentally captured in deep trawling nets. The adults, true giants of myth and biology, remain elusive, drifting in the quiet expanses where human lights have never reached. We know they inhabit the cold southern ocean, but not how far their range extends. We know they are powerful predators, but not the full details of what they hunt. Every new discovery brings more questions, as if the squid is deliberately keeping secrets the way a seasoned bouncer keeps a straight face. And perhaps that is part of its allure. The colossal squid is a guardian of mysteries, a creature that reminds us how little of the deep we truly understand. Its massive eyes stare into an endless night we cannot fathom. Its hooks grasp an existence shaped by pressure and scarcity. Its body moves through a world where time stretches slowly, and life follows rules many of us have never imagined. Down there, in a silent realm of shadows, the colossal squid stands as one of the deep sea's most formidable figures. Not because it roars or charges or flaunts its power, but because it watches, it waits. It grips the darkness with the quiet authority of a creature built for extremes. Call it a monster if you must, but in truth, it is the deep sea's bouncer, silent, steady, and always ready to keep the abyss in order. If there's one thing the deep sea does better than any rave, music festival, or neon-soaked night market, it's glowing. Down in the abyss, where sunlight has long since given up, countless creatures generate their own light with a confidence that suggests they collectively run the world's most successful glow stick industry. Blue flashes, green pulses, shimmering curtains of light. The deep ocean is an endless night illuminated not by electricity, but by biology. It's as if evolution decided darkness was boring and handed out bioluminescent starter kits to anyone who stuck around long enough. Bioluminescence, the ability of living organisms to produce light, is far more common in the deep sea than anywhere else on Earth. Up at the surface, only a handful of species glow. But once you descend into the deep, light becomes the rule, not the exception. If you're a creature living thousands of meters below sea level, glowing is about as normal as breathing. In fact, if you don't glow, the locals might look at you like you showed up to a costume party without a costume. But why light? Why in a place where energy is precious and conditions are harsh, would so many species devote biological resources to creating tiny underwater lanterns? The answer lies in the many uses of bioluminescence, that brilliant blend of chemistry and survival. It begins with the chemical reaction itself. Most deep-sea creatures produce light using a combination of luciferin, a light-emitting molecule, and luciferase, an enzyme that triggers the reaction. When these two meet, they create photons, actual light, without producing heat. This cold light is crucial. In the deep ocean, losing even a small amount of energy to warmth would be wasteful, and generating heat could actually harm sensitive tissues. So, evolution, in its mysterious craftsmanship, built a system that glows brightly while remaining cool and efficient. It's the sort of elegant engineering that makes you wonder if the abyss secretly hired a team of chemists. But the real magic lies in what creatures do with that light. Bioluminescence serves purposes that run from the practical to the theatrical, and sometimes both at once. Some species use it to find food. Tiny crustaceans flash like underwater fireflies to attract mates or lure prey. Dragonfish flash coded patterns along their bodies to communicate or confuse. Certain jellyfish emit rings of light when disturbed, sending glowing ripples through the water that distract predators long enough for the jelly to slip away. These displays aren't random, they're targeted, deliberate strategies honed through countless generations. Other creatures use bioluminescence for defense. When threatened, some squid release clouds of glowing mucus that drift away like shimmering decoys. Predators, startled or confused by the sudden brightness, often attack the light instead of the squid. It's the deep-sea equivalent of tossing glitter behind you while sprinting in the opposite direction. Meanwhile, shrimp, like Acanthophera purpurea, literally shoot glowing chemicals into attackers' faces, a maneuver that feels almost rude in its effectiveness. Then there's counter-illumination, a tactic so clever and stylish it could have its own fashion line. Many fish glow on their undersides, matching the faint glimmer of the water above. This makes them invisible from below because their glowing bellies erase their silhouettes. It's camouflage by brightness rather than darkness, a strategy that feels almost poetic. To disappear, they must shine. It's as if evolution looked at the idea of blending in and said, let's flip that concept inside out. And of course, bioluminescence is used for communication. In a world where sound travels strangely and visibility is nearly non-existent, light becomes a language. Patterns and pulses carry meaning. Attraction, warning, identification. Some fish have photophores arranged like constellations, each species displaying its own star pattern. You could imagine a deep-sea creature looking at another's light show and saying, "Ah yes, the unmistakable twinkle of Steve from down the trench." But no use of bioluminescence is more iconic or more mischievous than using it to lure prey. Countless predators have turned their light into bait, calling to unsuspecting animals with flashes or winks. Some dangle glowing appendages like fishing lines. Others create soft pulses to mimic smaller creatures. If the abyss ever held a workshop titled "How to Trick Your Dinner Using Light," the seating chart would have to triple in size. Everyone glows, everyone tricks, and everyone tries to outshine the competition. Why is this glowing phenomenon so widespread specifically in the deep sea? The environment itself encourages it. Light is scarce. So any creature that produces its own gains an immediate survival advantage, whether they use it to attract, distract, hide, or find each other. Bioluminescence becomes the currency of interaction. And because light does not reach the deep from above, everything glows at wavelengths nature didn't bother filtering out. Most deep-sea bioluminescence is blue-green, the color that travels farthest through water. It's the ocean's equivalent of using the brightest, most efficient bulb in the room. The arms race for illumination also plays a role. As predators evolve new glowing tricks, prey evolve their own counterglows. As prey develop new flashes, predators adapt to exploit them. It's a constant cycle of innovation, with both sides inventing new biological light technologies in a battle so ancient it makes Edison's achievements look like an afterthought. Down here, the deep sea didn't just invent nightlife, it perfected it. Perhaps the most wonderful thing about bioluminescence is how seamlessly it weaves light into the fabric of deep sea life. Out of need, survival, and a touch of evolutionary showmanship, creatures have turned their own bodies into beacons, lures, alarms, camouflage, and communication networks. The darkness of the abyss isn't empty. It's alive with moving constellations, shimmering signatures, and spontaneous performances. In a place where the sun will never shine, life shines anyway. And as you move deeper into this glowing realm, you can't help but feel like every creature is running its own glow stick factory, lighting up the ocean one tiny spark at a time. If you collected every deep-sea creature we've explored so far and lined them up in one place, transparent-headed fish, colonial superorganisms, balloon-mouthed predators, glowing bait artists, fuzzy-armed farmers, hovering cartoon octopuses, flamboyant cloaked cephalopods, and fishes standing proudly on stilts, you'd have a roster so bizarre that any extraterrestrial passing through Earth's neighborhood would take one look and say, "Ah, finally, someone who understands us." Because down here, in the cold, crushing dark, our planet has been quietly producing biology so strange, so experimental, so wonderfully unhinged that it might as well be Earth's unofficial alien incubator. We keep pointing radio telescopes toward the sky in search of life. Meanwhile, the deep ocean is sitting below us with creatures that break the rules so thoroughly, they might as well have written their own syllabus. Nothing about deep-sea life adheres to the categories we build for the ecosystems we understand. On land, we expect animals to have recognizable faces, limbs that point in reasonable directions, and behaviors that feel at least somewhat familiar. But in the deep sea, normality dissolves. Anatomy becomes fluid. Evolution stops whispering and starts yelling, and biology turns into a massive ongoing experiment conducted by an environment that refuses to play fair. Take the bodies. Deep-sea organisms have thrown out the usual blueprint entirely. Up here, skeletons and muscles provide structure. Down there, softness reigns supreme. Bones would snap under the immense pressure. Rigidity is a liability. So creatures become gelatinous, fluid, malleable, physical metaphors for adapting to hardship. Shapes warp into forms that seem more inspired by sculptures from surrealist art galleries than anything rooted in conventional physiology. transparent heads, ballooning jaws, elongated fins, drifting filaments. Each adaptation is a practical answer to a question we never even thought to ask. Even size becomes a flexible concept. While surface creatures grow within predictable limits, deep-sea species have embraced extremes, giants roaming the trenches, while miniature species compress entire evolutionary histories into palm-sized frames. The ocean's depths are a place where a worm can grow longer than a train car, while a fully grown vertebrate can fit comfortably inside a shot glass. It's biology with no consistency setting, where large and small coexist not as exceptions, but as equally valid solutions to an environment that makes no promises. Then there are the feeding strategies, many of which feel like evolutionary improv at its finest. Predators in the deep don't chase meals. They craft illusions, set traps, or simply wait with the patience of monks. Some lure prey with glowing ornaments that double as a dinner invitation and a death sentence. Others expand their jaws into living nets, swallowing creatures they could barely dream of tackling under different circumstances. And some gather their meals from drifting particles, turning stillness into sustenance. The deep sea rewards ingenuity more than aggression, and the animals here follow that rule with creativity so bold it borders on absurd. The communication styles break all expectations too. In an environment where sound can be lost or distorted, light becomes the dominant language, even though there is no sunlight to speak of. Bioluminescence becomes Morse code, camouflage, attraction, intimidation, and misdirection all at once. Creatures blink at potential mates, flash warnings at rivals, glow softly to vanish into their surroundings, or erupt in sudden bursts of light to confuse attackers. Imagine a neighborhood where every resident communicates exclusively using glow sticks and laser pointers, and somehow everyone understands each other perfectly. That's the deep sea. The reproductive strategies, those deserve their own award show. The sheer creativity of deep-sea reproduction could fuel an entire season of nature documentaries. Some animals wait years for a mate. Some store eggs in clusters that cling like ornaments. Some reproduce continuously without seasons. And then, of course, there are relationships so intense that one partner literally fuses into the other, becoming a permanent biological attachment. It's devotion on a level that makes even the most dramatic soap operas look understated. What's striking about all these adaptations is how consistent they are in their strangeness. This isn't a place where one creature breaks the rules while the others nod politely. This is a world where the rules themselves are optional. The deep sea is an evolutionary sandbox where nature experiments with ideas it would never try near the surface. High pressure, low temperature, scarce resources, and endless darkness combine to create an environment that strips life down to its most innovative impulses. And those impulses lead to solutions that seem alien, not because they defy logic, but because they follow a different logic than the one we know. Every creature of the abyss tells a story about survival. Survival not as a battle, but as an art form. They reveal that life isn't confined to the shapes and systems we're familiar with. It can stretch, glow, shrink, balloon, fuse, wave, hover, float, or stand on stilts. It can be delicate or monstrous, solitary or colonial, patient or opportunistic. It can grow from vents that boil water under pressure or drift silently through a cold expanse, untouched by sunlight for millions of years. And beneath all of this marvel lies a simple truth. The deep sea forces us to confront the limits of our imagination. We think we know what life looks like until we meet a creature with a transparent skull, a fish that grows to the length of a city bus by accident, or an octopus that flaps adorable ear fins like it's auditioning for a children's movie. We claim to search for extraterrestrials, but sometimes the most alien things on Earth aren't found in the sky. They're found in the dark water beneath our feet. The deep sea is a reminder that Earth itself is an alien planet if you just go deep enough. And its residents? They're the guardians of an evolutionary saga that rewrites biology with every pulse of light, every drifting shadow, every quiet, impossible adaptation. Down there, normal doesn't exist, only survival and the extraordinary creativity that fuels it. For all the remarkable, baffling, delightful creatures we've traveled with in this journey through the abyss, the most astonishing truth is this: we have barely scratched the surface. The deep sea remains Earth's final, most stubborn frontier, an expanse so vast and uncharted that even our most ambitious exploration maps look like someone drew a few squiggly lines on a football field and called it a day. The darkness below us stretches for miles, an entire alien realm hiding beneath the planet's sunlit skin. And every probe we lower, every submersible we glide through the black, reveals new mysteries waiting patiently in the cold silence. When we picture Earth, we imagine continents, forests, mountains, and ice. But the truth is that most of our planet is ocean, and most of that ocean is deep. Not, oh, that's pretty deep, but bone-crushing, light-swallowing, monumentally deep. Trenches so vast they could swallow Everest and still have room for dessert. Plains stretching wider than continents, ridges and vents and canyons carved by forces older than our species' earliest ancestors. And inside all this, life everywhere, woven into darkness like a secret script. Scientists estimate that more than 90% of deep ocean species remain undiscovered. 90%. That means for every barreleye fish, yeti crab, or dumbo octopus we've admired, there may be 9 more equally strange creatures drifting just out of reach. Imagine reading the first chapter of a book and realizing the remaining 9 chapters are still sealed in a vault because the author wrote them in invisible ink. That's the deep sea, a story unfolding in silence, one we are still learning how to read. Our tools, as impressive as they seem, barely graze the edges. Deep sea exploration is expensive, difficult, and dangerous. Pressure increases with every meter descended, and the environment becomes hostile faster than any technology can adapt. Submersibles must be engineered to withstand crushing forces. Remotes must navigate without GPS or reliable light, and every mission requires precision planning. Still, We go because curiosity is louder than caution, and humans have always been hopelessly addicted to the unknown. What we do discover often defies every expectation we bring with us. We find creatures glowing in colors we can't properly name, animals shaped like abstract art sculptures, microbes thriving in chemical conditions that would dissolve metal, vast colonies with behaviors so complex they seem choreographed. And every time we think we've stumbled across the strangest organism possible, the deep sea politely taps our shoulder and whispers, "Oh, sweet summer child, I'm just getting started." In fact, one of the greatest challenges scientists face isn't discovering new creatures, it's naming them. With so many species turning up, researchers are scrambling to invent names fast enough, and let's just say creativity runs wild. There are animals named after mythological beasts, after celebrities, after inside jokes no one outside the lab will ever understand. At some point, scientists collectively decided that taxonomy was basically an open mic night for biologists with strong opinions and weak self-control. And honestly, we're better for it. But the pace of discovery is accelerating, and at this rate, we may soon be introducing species with names like "What is thisus bafflei?" or "Please stop finding more stuffa perplexica." The deep sea isn't slowing down, and neither is our bewilderment. Yet, for all the humor in the naming chaos, there's a deeper meaning to it. Every new species added to our catalog expands our understanding of what life can be. The deep sea shows us that biology doesn't fit neatly into the categories we build. It grows, glows, stretches, shrinks, floats, fuses, and invents itself in ways we never predict. Every new creature discovered is a reminder of humility. A gentle but firm nudge telling us, you don't know as much as you think you do. And that's the beauty of exploration. Not certainty, but wonder. Not answers, but questions that open into more questions, like fractals spiraling into infinite detail. The deep sea is the closest thing Earth has to another world, and it challenges us to imagine life not as a fixed set of traits, but as an evolving symphony shaped by environment, chance, and time. When we study the abyss, we study possibility. The possibility of new ecosystems, new adaptations, new rules of survival. The possibility that life will always surprise us, and perhaps, most humbling of all, the possibility that we are not the creative peak of evolution, just one branch among countless others that found their own strange, brilliant ways of existing. So as we close this journey, remember this: the deep sea isn't empty. It's overflowing with stories, with secrets, with creatures so fantastical they make fiction look lazy. And while we're busy inventing science fiction aliens, real ones are gliding beneath us every day, living in darkness older than our civilizations, thriving in conditions we'd barely survive minutes in. We may one day explore the stars, but for now, the universe's strangest life forms are not light years away. They're right here on Earth, swimming through an ocean we're still trying to understand. And until we map the depths, study every trench, and illuminate every black corner of the abyss. One thing will stay true. Scientists will keep discovering new species faster than we can invent names that sound even remotely normal. And honestly, that's the best problem we could ever have.